Welcome to our exploration of weathering. Today we're looking at 4 processes: exfoliation, shattering, granular disintegration, and carbonation. Exfoliation is when outer rock layers peel away, often as a result of pressure release or thermal expansion. Shattering happens when physical forces like temperature changes or frost action break the rock into pieces. Granular disintegration involves rocks breaking down gradually into smaller grains, often assisted by repeated freeze-thaw cycles. Carbonation, however, is a chemical process. Here, carbon dioxide dissolves in water to form carbonic acid, which reacts with minerals, especially in carbonate rocks like limestone, causing them to dissolve. This is the process that leads to solution weathering and makes rocks soluble. In 1912, Alfred Wegener proposed the revolutionary continental drift theory. He suggested that all our continents were once part of a gigantic landmass called Pangaea, its edges fitting together like pieces of a jigsaw puzzle. Pangaea means all Earth, and was surrounded by a single vast ocean known as Panthalassa. As time passed, Pangaea broke apart into 2 major segments: Laurasia in the north, and Gondwanaland in the south. The term mega-ocean sometimes describes the extensive body of water that existed around Pangaea, while paleoclimate refers to the past climate conditions that Wegener and later scientists studied to support his theory. In 1961, Harry Hess introduced the seafloor spreading theory. His idea explains how new oceanic crust forms at mid-ocean ridges, where magma rises from below and cools to form new rock. As this new crust pushes the older crust aside, the ocean floor spreads. This dynamic process plays a crucial role in the mechanism of continental drift. Let's shift our focus to the structure of the Earth's lithosphere. Our planet is divided into numerous tectonic plates. Typically, we recognize about 7 major plates, including the Pacific, North American, South American, Eurasian, African, Antarctic, and Indo-Australian plates, plus several minor plates like the Juan de Fuca, Cocos, Nazca, and Caribbean plates. Notably, regions along the Ring of Fire, a belt around the Pacific Ocean, are particularly prone to earthquakes and volcanic activity. Countries like Japan, Indonesia, Chile, and others along this circle experience frequent tremors due to the active boundaries of these plates. When an earthquake occurs, it sends out different types of seismic waves. P waves, or primary waves, are fast-moving compressional waves that travel through solids, liquids, and gases. S waves, or secondary waves, are slower shear waves that only move through solids. R waves, known as Rayleigh waves, are surface waves that roll along the ground, causing both vertical and horizontal ground movement. And then we have L waves, or love waves, which are horizontal, shearing surface waves that typically cause a lot of the damage during an earthquake. Next, we explore some intriguing landforms. Loess is fine, wind-blown silt that blankets large areas and creates very fertile soil. Moraines are accumulations of unsorted debris deposited by glaciers as they advance or retreat. Mushroom rocks are formed by differential weathering where the lower parts erode faster than the upper cap, creating a mushroom shape. Stacks are tall, isolated rock columns along coastlines that result from prolonged erosion. Till is the unsorted sediment directly deposited by a glacier comprising a mix of clay, sand, gravel, and boulders. Earth's rocks come in 3 primary types. Igneous rocks are born from the cooling and solidification of molten magma. Sedimentary rocks are formed by the deposition, compaction, and cementation of sediments. These rocks are incredibly important because they often contain fossils, preserving remnants of plants, animals, and microorganisms that once lived. Metamorphic rocks are transformed from either igneous or sedimentary rocks by intense pressure and temperature, changing their structure and mineral content. Let's journey into the interior of our planet. The Earth is structured into crust, the thin, outermost skin of the Earth. Mantle, the thick, rocky layer beneath the crust. Outer core, a fluid layer composed mainly of molten iron and nickel. Inner core, a solid sphere of iron and nickel at the center of the Earth. Between these layers are discontinuities, sharp boundaries where properties change dramatically. The Mohorovičić discontinuity, or MOHO, marks the boundary between the crust and the mantle. The Gutenberg discontinuity separates the mantle from the outer core. The Lehmann discontinuity distinguishes the outer core from the inner core. A caldera is a large volcanic crater that forms when a volcano erupts so massively that its magma chamber empties, causing the overlying land to collapse. This dramatic event leaves behind a huge, bowl-shaped depression, which can later fill with water to become a lake. The process of a volcanic eruption is a fascinating, multi-step event: magma ascent. Magma rises from the chamber beneath the volcano due to buoyant forces. Gas expansion. As pressure decreases near the surface, dissolved gases expand, sometimes explosively. Fragmentation. The expanding gases shatter the rock, propelling ash, rock fragments, and lava into the atmosphere. Eruption column formation. The material is ejected, forming an eruption column that may reach into the stratosphere. It's important to distinguish magma from lava. Magma is the molten rock that resides beneath the Earth's surface. Once magma reaches the surface through a volcanic vent, it is called lava. This simple name change marks the transition from a hidden reservoir of heat to a visible, flowing force that shapes the landscape. Now let's compare two distinct landforms. A plateau is an elevated, relatively flat area that rises sharply above the surrounding terrain, often formed by tectonic uplift or volcanic activity. A delta is a landform created at the mouth of a river, where the river deposits sediments into a standing body of water, often forming a triangular or fan shape as it branches out. These two are very different, the plateau being a result of uplift and erosion, while the delta is built from the accumulation of sediment. Deltas come in several types, but three major forms are commonly recognized. Arcuate deltas, broad and fan-shaped, like the Nile Delta. Bird's foot deltas, characterized by finger-like projections as seen in the Mississippi Delta. Cuspate deltas have a pointed shape due to a more symmetric distribution of sediments. Each type is shaped by factors like sediment load, water flow, and wave or tidal action. Earth hosts a dazzling variety of landforms. Broadly, these can be categorized into mountains, plateaus, plains, valleys, deserts, coastal zones, deltas, and more. Although there isn't one fixed number, since geologists often subdivide categories further, we can say that the world exhibits dozens of distinct landform types. In India, the diversity is equally impressive, from the soaring peaks of the Himalayas and the expansive Indo-Gangetic plains to the rugged peninsular plateau, coastal plains, and island formations. The Indian landscape is a microcosm of Earth's geomorphic processes. We've journeyed from the subtle chemical reactions that dissolve rocks to the grand movements of tectonic plates that shape our planet. Each process, from the formation of calderas to the creation of deltas, tells a unique story about Earth's dynamic history. I hope this interactive exploration has sparked your curiosity and given you a clearer picture of the forces that continually remake our world. Feel free to revisit any scene, dive deeper into discussions with our interactive quizzes, or explore our additional modules on related topics like plate reconstruction and paleo-environmental studies. What do you think? Is there any scene you'd like to explore in even greater detail? Or perhaps a related topic you're itching to discuss further?